software engineer at the Microsoft Development Center in Norway. I am Swedish, but I lived in Norway for 1.5 years now. And today I will be talking a bit about engineering and continuous delivery at massive scale. There will be a Q&A in the end, just like all the other sessions, so prepare your questions for then. All right, so why am I the one talking about continuous delivery at massive scale? So like I said, I am currently a software engineer in a team called People Infrastructure. We are a infrastructure or backend team, and we provide people profile and profile images for both consumer and enterprise scenarios. And we do this through a series of backend APIs. And here I put some of the user-facing applications that we serve. So we have stuff like Outlook Mobile for both consumer and enterprise, OneDrive also for consumer and enterprise, and Xbox, which is a purely consumer-facing application, Office apps like PowerPoint, which I'm using now, or Edge. So if you have seen your name or your image in one of those applications or a few others that are also Microsoft services that we serve, hi, that was me. If you haven't seen your image when you were supposed to see your image in one of those applications, sorry about that, that might also have been me. Our services across all of these user-facing applications serve over 1 billion monthly active users, and they run on thousands of machines all across the globe. So to me, that is truly massive scale. All right, so the topic of this talk is continuous delivery at scale. What does that mean? I think we need to debunk this in a few steps and really start at the beginning. So firstly, what is continuous delivery? Well, it can be summarized as the ability to get changes of all types, whether there is new features, configuration changes, bug fixes, or experiments, into productions, really into the hands of your users, safely, quickly, and in a sustainable way. Sounds easy? Perhaps not, perhaps it isn't. But if it's done right, it can reduce the cost, the time, and the risk of delivering changes. And this can lay the foundation for things like rapid experimentation and innovation. So the second part, at scale. So when you start to talk about massive scale, does the way you do continuous delivery change? Does it mean anything different? Is the challenge different? That's what I'm going to try and talk about today. All right, so what is massive scale? That's the first step to figure out, because it can really mean anything. It doesn't come with a set meaning. So it can either be how many machines your service runs on, or it can be the numbers of contributors that your project has, or maybe the number and variety of users. When I think of massive scale, I think of all of these three, or a subset. And one example of a project that only covers one of these scenarios is the Linux kernel, which is an open source project. A Linux system really only runs on one machine at a time. And if I may say so, it only caters to a specific type of user. I'm one of those users, so no offense to anyone who likes Linux. But the massive scale of the Linux kernel project really comes from the numbers of contributors. In 2017, it had over 15,000 developers contributing to it, and I expect by now there are even more. So in my day-to-day life, I have all three of these. We run on thousands of machines simultaneously. We have a lot of contributors, both here in Norway, but also in other development centers that Microsoft have. We have, like I said, over 1 billion monthly active users, and they are all kinds from consumer to enterprise. So yeah, I have all three of those. And when the scale of the service goes up, so does the complexity of the solution. In a smaller system, there are a lot of edge cases that you don't have to consider. But in a very large system, those edge cases stop being edge cases and become valid use cases. So you need to take them into consideration when building your service. And to do that, while staying agile, fast moving, and continuously delivering, That is a truly delightful problem that I go to work trying to solve every single day. So to do this, we need a number of tools in our tool belt to handle this scenario. So I thought I'll start at the top and talk a bit about how you deal with continuous delivery when you have a lot of machines. And I think an example can be the best way of showing this. So you might think, why does the number of machines matter? Isn't your system distributed? Don't we have like all this knowledge and technology in the community that solves all of this for you? And yeah, that's a fair question. Our system is distributed, and there isn't really much need for communication between machines. So we're sort of lucky in that sense. So should be easy. We are also a one-hit service, meaning that we get a request, maybe the browser Edge requests a profile image, and then we do the server-side magic, and then we give them back the image, and that's sort of it. So again, sounds really easy, right? Well, yeah, but let's ponder this scenario. Your system is distributed, and you have large scale, but you have to take a dependency on a centralized system. Maybe you have to do this for a legacy reason, because you work in an old organization that has a lot of legacy systems that you need to work with. Or maybe it's a legal requirement. An example for us is in the USA, we need to scan images for documented abuse of children. That is a legal requirement, so we have to do it. It can be similar legal requirements, but maybe this requirement is really new or something that's just starting up in your organization. So this new system doesn't have the same scale that you have yet. They are just a small centralized service. All right, so we know this because we talk, so we know they're centralized. So the key here is to not take them down. No friendly fire allowed. We don't want to DDoS each other, preferably DDoS no one, but at least not your friends. So you design your service with this in mind. So you decide, I'm gonna just call this centralized service once per 48 hours per user. That shouldn't be so often. They should be able to handle this load. So you roll it out to one machine, and then you test it. You let it sit for like a while, and you're like, this is fine. They're able to handle the load. They don't even notice it. So you're like, it's gonna be fine. I'm such a great designer. Everything's gonna be awesome. So then you roll this out to production, to worldwide. But you don't have a staggered start. So you accidentally take the centralized service down, because all of them said, oh, I need to go sync every 48 hours, but I've never synced before, so I need to do it now. And yeah, we're caught in the friendly fire scenario, and we're not on that team's friendly list anymore, which isn't great. So how could we have avoided this situation? Well, we did something right. We tested in production, right? That is good, because that way we can get user feedback through usage, which can help us improve our service and test out what our users really like. But we did it sort of the wrong way. We did one machine and then all of the machines. So the trick is, when you do testing in production, you need to do it in increments. And if you have servers, maybe you call this rings. If you have user-owned devices like phones, maybe you call this A/B testing or batches, whatever you call it. The goal is to balance real customer feedback through usage with low risk of changes. So maybe you decide to have different rings, like an internal ring for only your team or only your company or a few phones. And you test things rapidly there. So for them, you deploy every single day. Whereas for the rest, you maybe only go once a week or every other week or every third week, whatever makes sense to you. Right, but there are other things we could have done in this scenario. So we could have done automated rollback. Sounds really good, right? Something goes horribly wrong in production, but it's detected automatically, and then the build is rolled back automatically. And it is great. But remember, it's automated, not automagical. So we need to define criteria. They need to be really specific, and you need to keep those updated. Because in the example I just mentioned, that was a new scenario. And it doesn't matter if we had like these awesome criteria from before, if they didn't take this new scenario into consideration, the rollback wouldn't have helped anyway. So here it's really a question of sitting down and thinking, what is critical enough so that my service should roll back? Because maybe that build also has critical fixes or new feature or something else that you really want to get into the hands of your users. And the important thing is to find that middle ground where it's not so strict that you never trigger it, even in the scenarios where you would have wanted it to be triggered. But it's not so unstrict that you're constantly rolling back, that it's hard to get new changes out because they so easily get rolled back. And especially if you share a deployment pipeline with other teams or services, this is very, very important to be mindful of. All right, so that was a bit about the first step. How do you deal with a large number of machines and continuously deliver? The second part is how do you deal with a large number of contributors? So I often say that software development is the world's largest team sport, except there is no Olympics, which my parents will forever be a bit disappointed about, but they'll survive it. So dealing with a large number of contributors, that can really be a factor that affects the continuous delivery process. So working for Microsoft, that means you get to work with people from all sorts of different teams, and they are spread all over the world. So it can be anything from a designer team, a front-end team, an AI or machine learning team, or some sort of intelligence. It can be an architect team, or it can be another backend team, you know, the ones owning that centralized service that you took down last week, those people, or a multitude of other teams. So for me, my closest partner teams, they sit in Seattle, USA, Prague, Czech Republic, London, UK, and in several campuses all over India. And sometimes we visit them. That's where the cute shuttle picture is from. So for me personally, in my day-to-day job, the issue isn't just the number of contributors, but also the fact that they are spread across the globe. So what could this give us? Having people spread across the globe and having a lot of people, that must give some benefits, right? And it totally does. So one example is for on-call engineers. On-call engineers is a role that is the person who, if something goes down, if something goes horribly wrong, that's the first person who gets a call and has to try and fix it. And if you're lucky enough to have people around the globe, the role can also move around the globe, which is called follow the sun, meaning that the person who gets that call for that very serious incident is already awake, it's already at work, has like coffee nearby, and it's already like all those steps are already done, instead of someone who's waking up in the middle of the night who have to wake up, find their computer, start it up, figure out what's going on. So that can really be a big benefit in your incident management system. Secondly, if you have a shared build or deployment pipeline, you're going to have less crashes because you are spread across the globe. So you're spread in different time zones, you work at different times. And I think most importantly, you get diverse perspectives and ideas. The more people you are, the more perspectives you're going to have, and that's going to build you a better service. And lastly, and there's a question mark on this one, is faster development cycles. So more people doesn't necessarily mean faster. It only means faster if your code base and your deployment tools can support these people. So if you have modular code, if you can deploy and build independently of each other, you can go a lot faster with more people. But there is also a flip side of the coin. Oh, this was not the animation I wanted. All right. So firstly, builds affecting your service could potentially roll at your night time. So your service has dependency on some other service, and they sit in some other part of the world. So they roll at their daytime, which makes sense because they want to validate and check everything when they're at work. But it affects our service in a negative way, and we are asleep. So even though we had this great on-call engineer, maybe they didn't know the specifics of your service, or it was very, very bad incident. For whatever reason, you get waken up in the middle of the night. Sad. Secondly, collaboration across time zones or when the team grows can be really challenging. Not only cultural differences, but also just finding time to schedule a meeting where everyone is awake can be kind of tricky. And lastly, I have this on both sides, shared build or deployment pipelines. This is especially true if you're a lot of people in the same place, because that means you might end up crashing or clashing with other people. And also when someone rolls something, when someone deploys something and they take 5 other services with them, you know, in the best case, everything's fine, just go together all the time, and that's good. But once one of those services needs that rollback and has to take the other 5 with them, it can be a topic of discussion, and it could be an interest conflict, and you can end up in all sorts of scenarios where you have to determine what is most important for the customer. Whereas if you would just have separate pipelines, this would never happen. So to counteract this, you take other preventative measures like slowing down the bake time, saying we only roll to test environment once per day, and rolling to worldwide is super, super slow, so that we avoid those scenarios. And we lose speed, and we lose parts of the continuous delivery. All right, so that was a bit about a large number of contributors. The last piece of the puzzle is how to deal with a large number of users and a high variety of users. So for Microsoft, the mission statement is to empower every person and every organization on the planet to achieve more. So the key to me here is every person on the planet. That is pretty bold, and it's a lot of people. And it is yet another thing that's going to affect your continuous delivery process. So how do you design a service for every person on the planet? And that is the question I try to answer every single day. So there's a few things we need to consider here. Firstly, accessibility is key. Why? Well, if you want to design for every person on the planet, every person is going to have different needs. And if your service isn't accessible with or compatible with a screen reader, then no one who has a visual impairment is going to be able to use your service. And that's a pretty powerful statement to put out, to say that I don't want your usage, I don't care about you as a customer. So that is really important. Also, if you design a gaming console that doesn't support usage with, for example, only one hand, people who are war veterans or perhaps children born without limb, they are also left behind. So this is very important. And here we can really make use of that good cross-team collaboration. Even though you might not be working on a user-facing application, you still need to consider this, because it is a lot easier to design with accessibility in mind from the start, rather than building your entire service and then try to plug accessibility in. So go talk to your local team expert, join forces with your UI team, and go from there. Secondly, representation matters. So for a few years ago, there was several companies who were in the same sort of scandal around Face ID, like different applications that would unlock your device with your face. And it turns out this really only worked well for white males, which isn't great. And this was to lack of diversity in test data. But perhaps if there had been diversity in the team, they would have suggested this diversity in the test data. So really, representation in the team will lead to diversity of thought. And that way you can design a solution that is for every person on the planet and not just people who are like you. So for me, for example, if I joined forces with only other Swedish young females, we would probably design something that was only good for other young Swedish females, which is not what we want to do here. We want to design for every person on the planet. I'm so sorry about this. Right, lastly, embrace users of all technical levels. Old people who are not that technically skilled are as worthy of our time as digital natives. But it can be hard to design for both at the same time. So here you can really make use of tools that we talked about before, like A/B testing in production, or really just getting your service into the hand of a diverse set of users and see what flies and what doesn't. Because if you're not someone who's old and having a hard time with technology, it can be really hard to step into their shoes. So you need to be customer driven here. All right, lastly, this is something that the CVP of my company often say, that scale plus innovation equals impact. And continuous delivery is a tool that enables innovation. And that is one of the reasons why it is so important, because scale on its own really means nothing. And when we have both of these, that is really when we can have big impact, and that is when we can change the world.